This lecture video is about graphing linear inequalities in two variables. So graphing a linear inequality and graphing a line are very similar. First you graph the line of the equation, and then you shade according to the inequality. So our first one is x plus y is less than or equal to 2. So first we want to graph x plus y is equal to 2. And when there's an equal sign, you graph it as a solid line. If there's no equal sign, you graph it as a dashed line. So this one we're going to graph solid because it has the equal sign. So the easiest way to graph when you have both x and y on the left-hand side of an equation are to find the intercepts. And when you're finding your intercepts, the opposite variable is equal to 0. So here we're going to find x-intercept, so that means that y is equal to 0. So if you replace y with 0, you'll get x is equal to 2. So our x-intercept is the point 2, 0. So here's our, this is x-intercept, so there's the point 2, 0. Make sure that you label your points that you plot, and then the y-intercept. Again, the opposite variable is 0, so x would be equal to 0. If you replace this x with 0, you get y is equal to 2. So we have the point 0, 2 for our y-intercept. And all you need is 2 points to graph a line, so we have enough points to graph our line. The next thing that you want to do is test a point. And if 0, 0 is not on the line, then that's the point that I always test. And I will usually put an X on my test point just so that I know that that's where I'm testing. So I'm going to test 0, 0 and see if that gets me a true statement in my inequality. So if I plug 0 in for x and 0 in for y, I get 0 is less than or equal to 2. And 0 is less than or equal to 2. That's a true statement. And so any point on that same side of the line will give us a true statement. So then you shade the side of the line that's true. So the solution for this then is any point that's in this shaded region. So our next example here is y is less than negative 1/5 x. So what we want to do is we want to graph the line y equals negative 1/5 x. And you could also write a plus 0 here, and then we would have it in the form y equals mx plus b. So our y-intercept, it's crossing the y-axis at 0 because that's the plain old number on the end. And so that gives me the point 0, 0. My slope is negative 1/5, and so our top number is the rise, and the bottom number is the run. And the negative sign you can either rise in the negative direction or run in the negative direction, but only one of them. So from 0, 0, we could go up 1. If we go up 1, that means we need to go to the left 5. We could go down 1, and then we would have to go to the right 5. So I have the point 0, 0. This point would be the point 5, negative 1, and this would be the point negative 5, positive 1. And we're graphing this with a dashed line. The reason that it's getting graphed as a dashed line is because this inequality does not have an equal sign. The first one that we did had an equal sign in it, so it got graphed as a solid line. So now pick some point that's not directly on our line. So I'll pick the point 0, 1. So if I plug 0 in for x and 1 in for y, will I get a true statement? So we'll have 1 is less than negative 1/5 times 0, and is 1 less than 0? And 1 is not less than 0, it's greater than 0, so that's false. And so we're going to shade everything on the other side of the line. Because the point that I tested here was false, so none of these points are going to work, and all of the points on the other side of the line will work. Our next one, 2x plus y is less than or equal to negative 5. So we want to graph the line 2x plus y is less than or equal to negative 5. So here we have it in the same form as we did up above, but since the negative 5 over here is not divisible by the 2, I'm actually, and the y is by itself, I'm actually going to write it in the form, oops, and I don't want the inequality in there, just equals. I'm actually going to subtract the 2x from both sides so that I have it in slope-intercept form. So that would be y is equal to negative 2x minus 5. And this will be easier to graph than this one, because then we'll have nice numbers to work with. So my y-intercept is this negative 5 on the end. And so that's the point 0, negative 5. And so here it is on my graph. And then my slope is negative 2. And you always want to think of slope as a fraction. So negative 2 over 1, or you could think of it as positive 2 over negative 1. And again, the top number is the rise, and the bottom number is the run. So from this point, I could either go up 2 and to the left one, or down 2 and to the right one. Since my point is kind of low, I'm going to use this form and go up 2 and to the left one. And then we could go up 2 into the left one again, get another point if we want. So this first point is the point negative 1, negative 3, and then we have negative 2, negative 1. And this gets graphed as a solid line. So the reason that we're graphing it as a solid line is because this inequality has the equal sign. And then we need to test a point. If 0, 0 is not on the graph, I almost always will test that one because it's the easiest one to test. And so we test it back up in our original inequality. If we plug 0 into x, this term will be 0. If we plug 0 into y, that'll be 0. So we'll just have 0 on the left-hand side. So is 0 less than or equal to negative 5? And the answer is no. 0 is greater than negative 5, so this was false. And so we don't want to shade this side because that was false. We want to shade the true side. So that would be over here. So any point in this shaded area will be true. Our next one, we have negative 2x minus 3y is less than 6. So we want to graph negative 2x minus 3y is equal to 6. And I'm going to leave this one in this form and find both intercepts because 6 is divisible by both the 3 and the 2. And so I'll be able to find my intercepts easily. And they'll be nice numbers. So for the x-intercept, y is 0, because it's always the opposite variable. So if y is 0, then this term is 0, and we're left with negative 2x equals 6. Divide both sides by negative 2, and we get x equals negative 3. So that gives me the point negative 3, 0, right there. And for y-intercept, x is 0. So if we plug 0 in for x, we'll get negative 3y equals 6. Divide by negative 3 on both sides, and we get y is equal to negative 2. So that's the point 0, negative 2, which is right here. This one's going to get graphed as a dashed line because there's no equal sign. And now we need to test a point. 0, 0 is not on my graph, so that's the point I'm going to test. So if we plug 0, 0 back up into our original inequality, if we plug 0 in for x, this term becomes 0. Plug 0 in for y, this becomes 0. So we get 0 is less than 6, which is true. And so we're going to shade this top part of the line here. So any points up here will give you a true statement in that inequality. The next one here is x is less than y, so we want to graph x equals y, or, oops, not 0, y, or that's the same as y equals x. And we're going to graph it as a dashed line because there's no equal sign there. And you can just plot a bunch of points here. X and y are the same all the time, so you would have the point 1, 1, and negative 2, negative 2. As long as x and y are the same, it's on this line. Oops, sorry, this should be a dashed line, not a solid line. And x equals y is actually the line that cuts the first and third quadrants right in half. So 0, 0 is on this line, so I can't test that one. I have to pick a different point to test. And it doesn't matter what point you pick as long as it's not on your line. So I'll pick the point 0, 2. And again, you can pick whatever you want as long as it's not on our line. And so if x is equal to 0, we would have 0 is greater than 2. And is that true? And it's not. 0 is less than 2, so that's a false statement. So it's everything underneath this line. Our next one here, y is greater than or equal to 2, so we want to graph y equals 2. This is a horizontal line. And it passes through 2. So you don't really need to plot any points to graph a horizontal or vertical line. And it gets graphed as a solid line because it does have an equal sign. And then this is y values that are greater than 2. So again, you could pick a point to test. We could test the point 0, 4. So put 4 in for 2. Is 4 greater than or equal to 2? And the answer is true. And so it's everything on the top. You don't really need to test for this one because it says that y has to be bigger than 2, so you know you have to shade the top half. Had it said y is less than 2, you would have shaded the bottom half. And that is our last example. And if you have any questions, let me know. Thanks.